Okay, we're back. We're live. It's Monday. It's 3 o'clock. It's Code Green, of course, because Code Green Monday, it comes together. It's an association. Okay, and don't forget, this is ThinkTech Hawaii. I'm Jay Fidell, and our Twitter handle. I can do this. Our Twitter handle is ThinkTech HI. There it is. Okay, so if you have any comments you want to make, any remarks, including wise remarks, you can make the remarks on Twitter, ThinkTech HI. Okay, and our special guest today, Guy Akasaki, who I have known since he was bar mitzvah. It's a long time ago. He's with Commercial Roofing and also GreenPath Technology. Hi, Guy.
How are you doing, Jay?
Thanks for coming down.
You're welcome.
Yeah, nice to have you here.
Yeah, it's been a long time,
You've always been into technology. You've always been a leader. You've always been pushing the edge. I know that.
Yeah, it's kind of like brain damage work, right?
I remember our early times together was right after your bar mitzvah. It was in the 90s, middle 90s.
Yeah.
That's 20 years ago anyway.
That's right.
At the Building Owners Association. You were
That's
such
right.
a star then. How was life changed for you?
How has life changed?
Yeah.
I think, as you kind of look at that, anything that you do, you have to really kind of progress on that. You cannot just stay at that platform. I say, without a progressive vision, you kind of stalemate, right?
So if you're following all the technology, all the latest and greatest, all the cutting edge stuff, then it would logically follow
Yes.
that you're still doing that today.
Yes.
Am I right? Yes.
That's correct.
I am.
Yes,
Are you doing that?
You are.
Okay, so tell me, Commercial Roofing, GreenPath Technology, what's the difference and which one is the one that's following all the newest and greatest technology?
Well, actually, when we're looking at technology, a lot of this technology comes as a result of transformation and evolution. When we started Commercial Roofing, it was primarily in the area of roofing. Very, very romantic topic, right? It was smelly back then, right? What we did was we looked at roofing from a different perspective. We looked at it from more of the energy savings, from the sustainability.
This is way back now.
And this was way back when. That was like when you and I were like only 20 years old,
Yeah.
right?
Kids,
right?
we were.
Yeah. So we were looking at that. We were looking at that benefit to be able to make things sustainable, reduce the energy consumption, because out of a four-sided building, I mean, what's the biggest plane that gets hit by the energy?
Sure.
The roof area.
Yeah.
So with that, we worked on things that would begin to migrate the energy savings, the sustainability, not having to go back to the dump or make reclamation land for an airstrip. And from that platform, we began to look at these things, and then hence, segue to that, we started to look at photovoltaics. Before the revolution of PV took off.
Interesting, because a lot of guys went the other way.
Exactly.
They went into photovoltaic, and when times got a little tough on that, they went to roofing.
Exactly.
You were always there on the roof, always.
Right. So what we did was, in that area of the roofing side, we didn't look at PV the way it is today. Back then, we were looking at PV to make it integrated. They call it BIPV, Building Integrated Photovoltaic,
How does that work?
where the photovoltaic assembly would become a part of the roofing assembly. Where
Put
you
it
can see
all on the
all
same
on
time.
the same plane, all at the same time.
Cool.
And by doing that, you're able to create a stability in the system, and also for hurricane, Hawaii is in a very high hurricane typhoon alley. It has the wind uploads. So you wouldn't have it blowing around. Like this last wind we had, I think there was a library that was recently done and some panels.
Tear it right off. Yeah.
Yes.
Yeah.
So at the end, that wasn't very high winds.
Yeah.
So what happens is when we look at technology, we don't look at the turnkey effect, the impact to old economy requirements, permitting, right? We think it's the coolest thing, right? It's sort of like suddenly...
You haven't changed at all. You're still a visionary. You were a visionary then, you're a visionary now. Sorry I said that.
Yeah, unfortunately, my eyes are getting worse. So. But I mean, as we look as photovoltaics, BIPV, we started to integrate that. As a matter of fact, one of the projects that we did was the Kauai Botanical Gardens, and that was using a BIPV. Now, hence, again, early on, right, there were a lot of guys who were jumping onto the bandwagon. And so as they started to look at projects that were being done in the islands, they started to bring different technologies. And just like a developer, they pulled the roofer, they pulled the guy who made the material, they pulled the finance guy, and they put it all into one pot, and then they walked away with the money. Had no skill sets, no turnkey understanding.
Let's throw it together.
They just threw the deal together, and they made the money, and some other people made a little money. But when problems happened, they ran away.
Yeah.
And that's what happened in many of these instances, along with some of the
I think there's a lot of installations out there where it's still going to happen.
And it still isn't over.
Yeah, sure. It's just beginning. You talk about climate change. But now the integrated idea about integrating the roof, that's still the case today. I mean, you can go either way, right? You can put it on the little stilts, or you can put it integrated in the roof.
You can do it as an integrated system, but at that point too, you have to make sure you have good slopes that the water will run off. In the integrated systems in its earlier stages, they were put flat. They were cool in terms of wind uplift, but in terms of dirt collecting on it, then all of a sudden the light wouldn't be able to get through, so you get low efficiency. So hence the onset of what they call applied photovoltaics. And applied phavoltaics was when they started to put the racking and the legs and tie it into the roofing. But with that, if you could say with the tax credits at that point, it started to come forward. We were already moving into the research and development for, the Office of Naval Research, for first responders, for war fighters, and this is non-glass module manufacturing.
Non-glass, what is
non-glass?
What is it? If it's not glass, what is it?
There's no glass. It's using a polymer facing, ETFE, EVA.
And the polymer is actually a solar cell?
It's actually, no, it's actually the laminating sheet that holds
instead of the glass.
cells.
The solar cell is down
Instead
under
of the
it.
glass.
But
Correct.
what about those stilts, though? As the stilts have grown, in popularity, have you migrated to that, or are you still integrating it?
We actually are doing applied photovoltaics, because now with the onset of the stilts and the things that you had mentioned right now, basically they had pre-engineered systems where you're able to kind of, with that racking type, that stilt type, to be able to engineer it for wind loads.
So you can get to the same result with the newest, most
Yes.
high-tech models of the stilts.
Correct, correct.
The other thing, we had a guy sitting in this very chair. Now, where was he from? University. And he had these steel brackets. This was in order to deal with climate change and bad storms.
Yes.
And you could affix the brackets to the underside of the roof, where the roof structure hits the joists,
Yes.
I guess.
Uh-huh.
And you put this on, the roof doesn't fly off.
Uh-huh.
Is this popular now?
Well, I think with the building department, right, they not only have the bracket, that's only one part of the connection, right? The connection actually starts from the slab. So with the type of
Right. It's all
requirements,
connected
you have
down
all
to
the
the slab.
anchors all the way down to the slab. So
Yeah.
even if you connect it from the roof framing down to the roof joist, if the roof joist isn't connected to the studs, and the studs is, hey, sounds like a rhyme.
We began singing at that point in the show. Connected the hip
got you,
bone
yeah,
and,
right.
and the ankle bone, all that.
Connected to the brain bone, but I have no brains, Jay. But I mean, you need that connection. So this is a turnkey side that I'm saying. As a gentleman might have said about the connection, to connect the roof joist to the roof framing, again, there's some common sense element that prevails that sometimes the dots are not connected.
So is this being done? Are you doing this?
Yeah, yeah.
Okay.
Yeah.
So a modern roof, I mean, in Hawaii anyway, has got to deal with the possibility of climate change and bad storms.
Mm-hmm.
And so any roof that you work on, you want to make sure it's
You want to make sure that it's tight, because again, the foundation of whatever you put and whatever technology you use, it's only as good as the foundation, right?
Yeah.
If I put $100 a gallon paint on the side of the building, but that thing is all rotten and wood rot, it does you absolutely nothing, right? So your foundation has to be sound. And like anything in life or anything in construction, your foundation has to be sound, familiar, right? And have set precedents, right?
And then what you hang on the outside of it, then it's worth putting some money into it because you get a basic frame is good.
Exactly.
So let's go to the technology that you favor. I mean, it sounds like you've migrated into a lot of high-tech solar devices and treatments and all that. And it's not only on the roof, but it's elsewhere too. I mean, you mentioned a couple of them to me.
Yeah.
For example, solar power air conditioning.
Yeah.
Really curious how that works.
The solar power air conditioning. Everybody looks at, well, let's put it this way. Because the tax credits are so attractive, people want to go ahead and put solar on there, right? Yeah. So we may go there and talk to the owners and tell them, what you ought to do is maybe put a water heater first. Because, by changing water,
that's fundamental,
basic. Get down to your baseline, right? Yeah. But because it's so exciting, no, I want to go PV all the way. I want it to take care of everything. I'm going, okay, but it's cheaper. You take off 25%, you cover less real estate on your roof, less cost to you, right?
So you recommend having one of those classical water heaters.
Water heaters.
And then for electrical generation, use the solar.
Yeah, off your baseline, right?
Yeah.
And then for the more sophisticated people, we recommend a heat pump water heater because that's a whole lot more efficient. But in Hawaii, people don't understand heat pumps. That's such a beautiful device. But
How does that work?
the heat pump, basically using thermodynamics. I'll give you an example of that via the solar air conditioner. The solar air conditioner, basically what it is that when we look at PV today, the industry is robust, but because the HECO's NEM approval process has really slowed everything down, really kind of killed the industry, right? So when you look at that, actually, we build our businesses based on a revenue model that is stipulated on welfare. It's because if we have the credit, we can do really well.
Yeah.
The government got to give us the money in order for us to do well. What happens if the credits are not there?
It's not going to happen.
It's not going to happen.
But they're going away in the Fed, they're going away next year.
2016.
Yeah, it's going down from 30
To 10.
To 10, yeah.
To 10. But at that, the state has every year has put before the legislature, right, to kind of get rid of
What
that,
happened
right?
this year? Anything?
Well, it's still on a docket to kind of take it out. But you know what's going to happen when 2016 comes and it goes down, the state's going to say kind of finished, right?
Yeah.
And basically, I mean, the initial credits was there for the purposes to encourage people to get into PV. And everybody builds their model on that credit and say, you are green,
Sort of
I am
spreadsheet,
green.
yeah.
Yeah. And it makes sense from a financial
On the
standpoint.
credit.
But
No
if
credit.
the credits, it's gone. So from a business perspective, does it make sense to build your entire future based on that credit and in hopes that the government is going to put that forward? We tout the beautiful renewable energy that we have here in the state of Hawaii. And then on the second part, we sit back here and we says, I want to get this. But the minute the dollar signs come up, whoa, unless they get free money, I'm not really going
It's
to
just
move.
a psychological point. You know, if I look across the way and a guy across the street, he got it and he got the max credits
Yeah.
a year or two ago. Okay, and then now I've been late, you know, I didn't pay attention. And now everybody's telling me I should do it or else. And then I look and I say, oh, I'm not going to get the same
not gonna get
spreadsheet.
this-
I'm not going to
yeah.
get the same,
Right.
you know, buyback and all that. So, so I don't do it. And if it goes down to 10, I don't do it at all.
But
you know.
it's a difference in mindset because both you and I realize, remember when mortgages were double digits?
Yeah, sure.
Remember on CDs we're getting double digits?
Yeah.
Remember when we got a 1% drop on double digits, we said that was a good deal? And today, at single digit, 0.25%, and people are crying,
Yeah.
right? Back then, we only made 10%. Today, on a CD, we make less than what, a percent?
Yeah.
Now, what's going to happen? People are so used to this welfare that they want the payback. What happens when it goes away? We go back to what we
So what's
accepted
gonna-
for before, but we got so used and so acclimated to entitlements, the word I quote, say entitlements, welfare, that we assume that's due to us.
Yeah.
But when it goes back to reality, we
Yeah.
really have to look at those things. So even though it may go down to 10%, there is still a payback.
There's still a reason for it, yeah.
Absolutely. But because it's not there, there's going to be that season, well, and then eventually, yeah, I guess I got to do it because I'm going to
But
save.
not as many people.
Not as
I mean,
many
if the
people.
utility is,
Correct.
you know, still there and you can still buy power and, okay, so I'm paying more, but I don't have to pay a big lump sum and all that. I don't have to make loans. So I think a lot of people are just going to fall back on the old system, not really care about it.
Which is true.
Yeah.
So when we look at these different things, like the technology that we have for solar, like a solar air conditioning, again, we looked at that 3 years ago when the economy was robust, the industry was robust. I said, we cannot really rely on welfare.
You were right.
And secondly, we need to be able to look at the fact that, you know, renewable energy is our biggest commodity.
We've got to find creative
How can
and
we use
high-tech
it?
ways to use it. You're there, and when we come back, I want to find out more of the things that you're offering. That's Guy Akasaki, and his daughter is here. She's Dana. She's in the back. I'm waving at her now. Hi, Dana. I know she wants to be at this table.
Yeah, you should put her up here.
Yeah,
Make
she
her
is
come
also
here.
with commercial roofing and GreenPath Technology. Her father's daughter, so to say, here on Code Green, and we're talking about energy efficiency for tomorrow. We'll be right back.
Yeah.
Hi, I'm Ethan Allen. I host Likeable Science on ThinkTech Hawaii, and I do this because I care about science literacy in Hawaii. I want to spread the understanding that science is a vital and interesting part of everyone's life. I want to make sure the broadest possible spectrum of people understand the beauty and the value of science and realize that science plays out each and every day of their lives. I want you to understand that science is fun. So we bring onto this show each week guests who are scientists, from astronomers to zoologists, and we talk about what they do and how they do it. But most importantly, we talk about why you should care about their work, why you should see that their work has value and impact on your life. So I hope you'll join us Fridays, 1 p.m. here on ThinkTech Hawaii. You can watch us via live stream. You can watch us recorded on Olelo, and you can see us each week. We hope you'll join us.
Yeah, we get a lot of people. Okay, we're back. We're live with Guy Akasaki, Commercial Roofing and GreenPath Technology, talking about the latest and greatest in technology that you can put on your house and your life, actually. So let's go back to the air conditioning, solar power air conditioning. Qu'est-ce que c'est que ça? That means, how does it work? Actually, what is it?
It actually is a little box with 4 mice inside. And in that mice, you have a square piece of cheese.
It comes with a
Being
lifetime
funny.
supply
Lifetime
of
supply.
mouse feed. Yeah.
Mouse feed. Yeah. You just got to be able to clean out the residual. But basically what it is, it's, if you can imagine a ductless air conditioning system, like a Fujitsu, a Mitsubishi, and that's basically what it is. It's technically a heat pump.
So is it, okay, and
what it is that the outside unit and then also the inside unit. The head that you see on the inside and then the outside unit, right? That's like a ductless. That outside unit is actually a DC unit. Everything in it is DC. The solar panels, it runs off of a maximum of 900 watts, 39 volts. And with that amount of power, just from those 3 panels, you're able to harvest the DC electricity directly into the outdoor unit.
more efficient that way?
No, it comes in, it doesn't go back to the grid. It doesn't go back, and that's where the NEM and the approvals come
You
into
don't have to worry about
place.
interconnect on that.
No interconnect. It harvests it directly into the unit, and it powers the air conditioning directly from the sun during the peak demand time. And so during that time, the sun is powering your air conditioners. Now, given for small businesses, absolutely great.
Yeah.
Because when do small businesses work? During the peak
day.
demand? During the
hot-
day.
Yeah, yeah.
So if you're able to run air conditioning off of panels, it works. An example, I have a warehouse down in Waipahu. We had it on 3,000 square feet, upstairs and downstairs. I engineered it for a 5.5-ton central system while I was vetting this about a couple years ago. We put in the air handler, the ductwork, the air conditioning, cost about 80 grand. That's about pretty competitive market numbers. If I had vetted this product already, I would have put 3 upstairs and 3 downstairs. That would have given me close to 6 tons, right? A half a ton more. The cost to install it would have been $38,000. With the tax credits, about $26,000.
Yeah.
So 80 versus 20, I would have built the next bay, the next set of offices ahead of time, if I knew that ahead of time.
Yeah.
Now, granted, my whole entire roof of my warehouse is covered with PV because I've done internet
You have to find
connections.
space for it.
And we did, but we ran it as a beta, right, to test it. But for a small business, if you were renting from a landlord and you need to run AC, 3 panels, would the landlord be willing to do that? Probably
As
so.
his project or your project?
As his project or yours.
And you advertise it off the rent?
Yeah.
Over time, yeah.
So there's different things that they can go ahead and model that.
That's a great
So
product.
it's a great product, right? And then from the homeowner, he said, well, you know what, I don't come home to the end of the day. So at the end of the day, the sun is down, there's no sun. So it's not gonna run. The panels are not gonna power the unit. I said, oh, you get an A+. What school did you go to? And then I kind of switched it. I said, let me ask you a question. Do you drink coffee? And that really throws them for a loop. And they went, coffee? What's coffee got to do with air conditioning? I said, follow me. Do you drink coffee in the morning? He goes, yeah. So what do? You brew coffee? He says, yeah. Then you take your cup out of the cupboard and you set it on the counter. When the coffee is brewed and after you wipe the gala from your eyes, you pour the coffee into the cup and then you're gonna drink your coffee. But what happens to your coffee? It gets cold pretty quick, right? Now what would happen if I went ahead and put hot water in that cup and then I took the water out and then I put the hot coffee inside it? And they always answer, oh, the coffee will stay hotter longer. What you naturally do in the course of the quality of life that we don't realize that we are rocket scientists. In that simple illustration, yeah, I've just identified for you the principle of thermodynamics. The ability to move energy from one state to another via the cup being cold, putting hot water, and carrying that thermal energy. When you wake up in the morning, your house is cool, your floor space, your walls, everything is cool, it's static. You put a timer on this unit and you turn on that timer during the peak demand times when the power is running off the panels, and you let that air conditioner run while you're at work. And then at 3:30, you have a timer, it shuts it off. So you've kept your house, your walls, your floor cool. You've kept it neutral, just like it was in the morning.
When you come home,
and when you come home and you're upset because you're sitting for 3 hours in that traffic down on the freeway, and you got all this road rage, and then you come home and you open that door and it's like hot, you're like, oh, irritated. You jam that AC on, right? And then what has to happen is you have to move all of that heated energy via thermodynamics again out to neutral before you can even start to cool. And that's why the biggest consumption period from any utility is during the peak demand time during the day.
This is when people come home.
And after people come home.
Yeah.
By doing it in this fashion, and again, because it's DC, you save a heck of a lot of electricity.
But
now,
and you can have a timer.
A timer, that's exactly
Set
what I'm
it up
saying.
any way you want.
Any way you want to. So this is a way that you can actually harvest the renewable energy that we have. And because of the credits, you still can get it, but you don't need permission. You don't need to get the approval
I like
for
that part of it.
the net, the net metering approval, right?
Yeah.
And then you can use it to even augment if you're in a fully saturated.
So the idea there would be that you dedicate the solar to one big use in the house, and then use all this technology to make it happen at the right time.
Yeah.
Is there anything else like that? I mean, for example, I don't know, refrigerator.
Yeah.
Why couldn't you put that same solar system on the refrigerator just the same way?
Because basically what that system over there, the air conditioning system, is keyed in to be a DC unit first. And being it's a DC unit, it can harvest the DC power directly from the panel. With the refrigerator, it's an AC unit. So you'd have to convert it, right?
Mm-hmm.
So there's a lot of things in that
Inefficiency.
transition.
Yeah.
So why is it that we use AC electricity versus DC? DC is so much more efficient. Why did we not use DC all the time? The problem is AC electricity is alternating current, 60 hertz. On a median to run wire or power over a long haul, AC is most efficient. If you were to try and run DC electricity, straight line, out there, it wouldn't go long distances. You'd have to have the median that could carry that power.
That's why you can use it for this.
So that's why you can use it. You want to be able to convert things to a DC basis, because when you do that, that's where the efficiencies are. But every time you switch from an AC to DC to DC to AC, or you combine a combination of the two, you cause what they call a derating. So the efficiency
Transformer
drops.
kind of thing, an inverter, I guess.
Yes, right. So it begins to drop. So when you do it in this fashion, it works. Now, the other thing that's come out, just like we said with PV contractors versus the roofing, all different types of products come to the table.
Yeah.
And you think, what kind of products? Other solar air conditioners, because you know what, with PV contractors as well, we're in a place where they're getting shoved into a place where they have no revenue. They have to look for things that will work.
That's what's happening for sure.
Right? And so things come on the market and you think, does it really work? Right? It's like wrinkle cream. Same thing,
Well, that's
right?
true. And
Right?
I think you run into that now because they may not know exactly how the thing works. And if they're not experienced in this product, you could get a pig in a poke.
That's exactly what it is. So there are different forms that in a laboratory it works. You know, simply again, when we come back to thermodynamics, when you think about thermodynamics, you think about the coils, the compressor, and the air conditioner, right? You heat up you turn on a compressor, it starts to squeeze the refrigerant into a compressed state. When you start to press the gas and compress it, it heats up.
Yeah.
And that's the backside of the air conditioner,
Yeah.
right? And then when you start to let it cool, coming back the other way, it starts to turn into a gaseous form, and all of a sudden it gets cold. So that's what you capture in that side. So thermodynamically, if you're able to superheat the backside of the coil using whether it be water heater panels or different coils to run off the backside, what do you do to the compressor? You technically make the compressor work less hard.
You know what this reminds me of, Guy? It reminds me of something I saw on the roof of Whole Foods in Kailua, the new Whole Foods one. It was called desiccation. And it's a old-fashioned tubes with water in them, and these tubes drive a desiccation machine, and the desiccation machine dries the air out, and that's the air that goes to the existing air conditioner, which in that case runs, I think it runs on ordinary, Hawaiian Electric power. But when the air gets in the air conditioner, because it's desiccated, all dried up, it's easier on the air conditioning system. So it uses like 40% of the power it would otherwise use. And so all these little and I suppose if you used solar to drive the air conditioners, it would be all that much better even. But the desiccation is interesting because it's actually old technology with new materials.
Well, what it is, it's the integration of components into a working system.
Yeah.
So the success of any product or system, right, is really in the interface of the components. The failure usually is going to be not in the components, it's the interface of that component into that system.
Well, that's what you said before the show. It's all about integration. You have to know what you have out there. You have to know where it works most efficiently. That's why we're calling this energy efficiency for tomorrow.
Right.
And you have to be able to integrate it. It's just like computer technology. Each little piece doesn't mean anything unless you can integrate the hardware and the software.
So remember when they had the IBM 808s? When you turned it on?
I can't remember that.
DOS?
Far back, yeah.
You turn that click on and you're sitting over there and it's going, clack, 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 clack. And we're going, whoa, this is amazing. And you're sitting there for 15 minutes going, this is amazing. Now, millisecond is too long for us.
Yeah, I used to have cars that did that. Only kidding.
Just crank it up.
What's going on? Okay, so now you got chemical technology, and you mentioned before the show that there's a coating going on from Israel. It's an elastomeric. It's a water-based urethane, and that could be a contradiction in terms, an oxymoron, as it were.
Yeah.
And what does this do, and why would I consider using it?
One thing that we look at is that we look into a lot of coatings. As you've heard, like I look at the integration of the parts, I look at the formulation, the interfaces, and then we look at the turnkey applications, right? And maybe I'll go into a little bit in the first responding type of panels that we make. But in the coating arena too, when we see all the coatings that are on the market today, we see white. So do we say all whites are equal?
White,
kind of like the white coatings.
Reflects the sun
Yeah,
back.
reflects the sun, that they're all pretty much the same thing, right?
Yeah. And that's a roofing concept. That's been in roofing for a long time.
Yeah. So do you think it looks white, so it's all the same thing? You'd be amazed how different they are. Because at the end of the day, it's really the formulation, right? Coatings are made of polymers, which is the major component. It's made of TI, titanium dioxide. It's made of skein, or a mildew-side, a form of mildew-side. And it's also made, the balance of it is made with a filler. So whenever you look at a paint shop, you go to a coating, you'll notice inside the label, material label, it'll say X amount of product, it'll say 60% solids, 40%, 30-something% fillers, and a few other names inside of it. We don't know what the heck it is, just like us reading what we eat. Same thing. But to us guys, and to me, I know exactly what that means.
It's material science. I mean,
it's material science is exactly what it is.
The Israelis or whoever's doing this, because this, it looks the same, but it acts different.
It acts different.
And so how different does it act? What can it do for me? Say, I don't know, on my solar panel on my roof?
This would be used on a roof area. Like in Hawaii, we have a limited amount of land mass. So everything ends up on what? The roof. And if you have a restaurant, everything is on the roof. And a lot of times people are supposed to service their equipment, their fan units, right? How often do they actually do that? They usually don't, right? It's when the vent starts kind of backing up, they decide to go up there and clean the vents.
Schmutz. It's schmutz. The schmutz goes up
Schmutz goes up, right?
And it corrodes the material.
Corrodes the material, but what else does it do? The animal fats and the grease end up on the roof.
Yeah.
And every manufacturer in the market today, with the exception of a special treatment that they have to do that, generally via sacrificial sheets of certain coatings, to take the abuse of the animal fats in order to migrate and keep the assembly in good shape. In this one over here, animal fats and chemicals don't affect it.
I mean, it doesn't intrude into the
It doesn't
into
intrude
the
or break
substance
down,
of the roof, into
the
the,
assembly itself.
that's pretty
So
good.
now for Hawaii, you know, places where you have so much blow off, we have so much grease traps, it's perfect for that kind of environment. And it still has, it has a high resiliency to UV. It is a cool roof, has low emissivity, high solar reflectance, and the water that catches off of it is potable. So you can actually drink the water that comes out this coating. Now when you think water-based urethane, it's like you said, it's oxymoron. How can water-based be the same together with the polymer?
Yeah.
They've developed a polymetric combination that works. So even when you spray it, urethanes, generally you have to use a PPE, as we say in our trade, personal protective equipment, certain filters. This requires nothing. You can be spraying.
So it's easy to apply then.
Easy to apply, very easy to apply. Very amazing, amazing product. So as we look at different technologies, these are the things that are impacting our quality of life. So that if we kind of keep our eyes open, we begin to see. But we cannot look at something and just say it's new because they say it does. You really have to know the
have to research it.
foundational stuff first and understand how generic and how better quality products work. Like I mentioned about the polymers. You know, who is the polymer manufacturer? Is it Dow? Is it Roman Haas? And if it is like Roman Haas, which one is it? Is it the 2219, the 2222? And then you have to look at the makeup of that polymer, right? You know, when we look at roofing, it's always been about transitions, right?
It's exactly right. It's about transitions. And we're going to have one now.
Okay, that's a good.
Inspired by an ancient culture, classical Chinese dance, vigorous physicality, timeless stories, 5,000 years of Chinese music and dance. Shen Yun presents authentic Chinese culture. Coming to Blaisdell Concert Hall, May 8th and 9th. Tickets at shenyun.com or call 808-792-3919.
Hi, I'm your host on ThinkTech Asia, Bill Sharp. I look forward to you joining us each Monday between 4 and 5 o'clock when we film right here in our studio in downtown Honolulu. The show, ThinkTech Asia, focuses on contemporary events in Asia. And by Asia, we mean anything from Hawaii, south to Australia and New Zealand, west to Pakistan, and as far north as the Russian Far East. Clearly, this is one of the most economically dynamic centers of the world, and we bring you up to date on what's going on in a whole host of countries in this very vital region. We look forward to seeing you. Aloha.
Okay, we're back. We're live. We're here with Guy Akasaki from commercial roofing and GreenPath Technology here on Code Green. And we're talking about energy efficiency for tomorrow with all kinds of new technologies. So, yeah. So I get my point during the break was you really have to know. The problem is that, you know, every installation you make, every roof you process or install, every solar facility is really it's a metric of how well you do. And in a small community like this, they all got to be good. So that means you got to get the books out and you got to review these products to make sure you're getting the one that really works, because in a world of you know, chemical technology, but material science, there's a lot of stuff out there that doesn't quite work too, right?
You're absolutely right. It's sort of like Hawaii has a community center. And what is that community center? It's Costco. And if I provide Jay something and I happen to be going to get ice cream, I see Jay walking up the ice cream aisle, I'm going, oh no. Then I dig out the other one, I see Jay's wife. Hawaii is a very small population base. Yeah. At the end of the day, it's the integrity of the process. So you better know what you're doing. Yeah. And you better know that it's not just providing something that you just want to sell, that it's something that is of necessity, that interfaces into the quality of life. Otherwise, then you're just trying to make a fast
So how do you
buck.
find out about these things as possibilities? And then how do you confirm that they're really what you want to sell?
Well, what we look at is that, first of all, we look at old technologies, and we look at the integration, I mean, not the integration, but the advent of different technologies going forward. Same thing that had happened in like, say, roofing. You remember when roofing, back our young days, you could tell when a roofer was around, right? Because we're actually Honolulu's finest crooks, liars, and thieves. But back then, how could you tell a roofer was close by? By the smell. Remember
Oh,
the
really?
pots?
Yeah.
Remember the tar pots?
Tar, yeah.
And when you think now,
Yeah, no
when you
tar,
think of any,
no tar,
you hardly ever see those kettles around
no tar.
because the technology has changed. Asphalt, when they cut asphalt kegs or
Yeah.
barrel of oil,
Yeah.
the refining and the technology in cutting oil has gotten so well and so fine that the residual in the asphalt is not even good enough for roofers. So what do roofers do? They add different elements like SBS, atactic polypropylene, different polymers to say that now we have a modified bitumen capsule that has resilience and strength. But they had to modify the old stuff and they charge you more and give you more life expectancy. So again, they take in some of the old things they find the lack of and then they modify going forward, right?
Well, that's a question I wanted to ask you, you know. Some of these new high-tech coatings,
Mhm.
I mean, coatings, it's a whole
Yeah.
science all in
Yes,
itself.
it is. Yes, it is.
Coatings are so important now in everything, I mean, from rocket ships to roofs.
Absolutely.
But it's more expensive. Some
Absolutely.
of these high-tech, it's like drugs, you know. You can find a little pill that costs you $1,000, a little pill. Be great, you know, really work, but $1,000. It may or may not be covered by your insurance.
But along that lines, what you're just expressing is the industry of nanotechnology. Nanotechnology, the pharmaceutical industry is spending a lot of time in nanotechnology. Why? Because by making drugs or pharmaceuticals the size of a nanoparticulate, 1/800,000th of a strand of hair, you're able to take the major component, things that we take in America orally, of 100% of the medication, only 10% gets in because 90% gets knocked out by our immune system. With nanotechnology, they're able to take the element, which is the key part, which is the 10%,
And deliver it.
and deliver it, bypassing the system.
Yeah.
But the pharmaceuticals would say, I'm going to charge you $1,000 because there's no side effect. But the side effect is as a result of our natural immune system.
Yeah.
So we begin to understand the technology and how it interfaces into who we are, and then we become a little bit more wise, right? So as people come to the market with right intentions, they begin to see this makes sense,
Yeah.
right? Rather than listening to a fairy tale, right?
Yeah.
So such as the same thing when we're doing the first responders and the modules that we manufacture the non-glass. In Hawaii, many people don't know, but we actually manufacture in Hawaii
What? What do we manufacture?
non-glass photovoltaic modules. We manufacture
You
here in
do this?
Yeah, we actually have a manufacturing facility in Kaka'ako on
Is
Ilani
Dana
Street.
involved?
Yep, she's involved in that too.
Hi, Dana. Manufacturing in Hawaii, huh?
Manufacturing in Hawaii.
How do you, that's quite a, that's formidable.
It is.
To
it
make
is.
a manufacturing facility in
It
this
is.
state, anywhere in this
So
state.
that's why we get funding from certain different entities to develop things for the marketplace, right? And one of them is this non-glass module. We actually have the components, the ETFE, we have the EVA polymers, we have the cells, we have the backsheet, we have all of the trace lines, all the things that are necessary. And actually my partner, Jim Cheney, he's our mad scientist, right? He's actually a guy that actually manufactured.
Every tech company has to have one, you know?
Yeah, and he actually made the lamination machine, which is something that you can buy off the market. Because the product is so unique, we need to have certain criteria. When you see the glass modules that are being sold today, nobody can do it cheaper than China.
Interesting.
But in that process of lamination, they have to do it under zero gravity, under zero pressure, right? Total there, and it has to be constant heat that goes through.
So what is the manufacturer doing? I'm getting the sense that there's a solar panel. Usually you have glass on the solar panel, but in this case, you're not using glass on the solar panel, using some kind of coating on the solar panel, and you're integrating various elements into that coating to get the result you want.
I'll give you a picture so you can kind of imagine in your head. We're like baking a cake, a multi-layer cake. We have a table, a heating table that we put it onto.
Yeah.
We set this thing in place.
This is the solar panel
This
itself.
is the solar panel itself. The first layer of the cake is like an IC board, like an integrated circuit board,
Yeah.
a fiberglass circuit board. And it has been dried out so that any of the vapor moisture is taken out of this. We
Okay.
put it through dryers. The next layer is the EVA, and that's like the glue, but it's a polymer sheet.
What's EDA?
EVA is a plastic sheet. It would be another
Plastic
layer.
sheet, okay.
And then
It's like making a surfboard, eh?
very similar, very similar is what they call composite construction.
Okay.
It falls under the category of composite construction.
Okay.
Then we put the cells, the silicon wafers.
Okay.
the cells. And
The
then
actual cell.
The actual cells itself.
Usually you don't buy them separately like
No.
that. You got to get them special.
We buy them separately.
Okay.
And then we connect them together into a string.
So you're making a panel.
We're
is
actually
what you're
making a
doing.
panel.
It's a non-glass
Non-glass. And then we put the top of that, the next layer of that cake is the EVA again, and then the next layer is a special surfacing material.
So you're
and that's
surrounding
exterior.
the actual cell with you're making a sandwich.
Yeah. And then we take this whole thing and we put it into the oven. This is a lamination machine. Lamination machine closes down, and it goes through a process of heating and drying and evacuating all of the pressure altogether. And after that period of time, the temperature starts to heat up the polymers, they interface, and they lock like an adhesive.
Really tight.
Really tight. Now there are criteria, heat, temperature, everything that you have to meet in order to do that. When it's finished, it comes out, and then we do the things we need to make it into the module that we use for this. Now,
Why would you want to use this instead of glass?
because it's light, we can take a 250 watt panel that weighs about 40 pounds, right, the glass module. The same module, 240 pounds, 250 watts, excuse me, not pounds, that weighs 40 pounds with the glass, will weigh it will weigh about 12 pounds.
Wow.
And it can
so
fit,
is that-
you can carry it under here.
that's-
And why do we do that? It's much more expensive, but it's made so that it can be deployed together with our portable power supply, which is a bank of batteries, lithium iron phosphate, so that they can take it out to a refugee, a first responder, CAT response.
That's
They can
why.
drop out the panels, and in less than 10 minutes be generating 4,000 watts daytime hours and 2,500 watts during the night.
It's a kit. You're
It's a
making a
kit.
kit here.
So what it is during the day, you're charging up the batteries, plus you're using the excess power to power the units during the day. And then at night, when there's no sun, you've got it charged up. In the day, when it comes up again, when the batteries are dead, you're using the power of the sun while it's still charging the unit. So it's not a UPS, it's actually very, very organic.
Yeah.
But in this, in the development and manufacturing of these panels, again, if you look at it, glass is very smooth. We also made this for the warfighter. And the warfighter, they call in UAVs, they have call in radio communications. So their battery, lithium iron, the BB2590s, they have to charge those.
Yeah.
So they put these panels out there, and if it was glass, what do you think they become? The soldiers become sniper food. Now, you can see the glass thing a million miles away.
No reflection with this other material.
With ours, there's a surfacing that occurs with stippling on the surface that allows the sun to refract the light to a higher efficiency in the cell.
It also doesn't break like glass.
Exactly. Actually, we've already tested that turnkey. What are the chances that military personnel will not get hit by shrapnel or by bullets? Pretty slim. They're going to get hit once, right?
Yeah.
We actually took this panel and we shot a 40 caliber and a 9mm Glock randomly.
Yeah.
9 holes, and we only lose the
And
power
no
where the
split.
holes are at.
Right.
So we still had a 96% efficiency
Right. You're the only guy doing this?
doing this to this degree.
Yeah. Well, cheer up. Nobody is going to know about it.
Yeah. And then the other part of this thing, when you're looking at the resilient side, is that we have what they call a mil-spec 810. When you do stuff for the military, you have to hit a certain standard, and it's called the mil-spec 810. There's a series of certification that you have to go through. Nobody ever passes it the first time. Ours passed the first time. We finally got the sample back. Oh, that thing looked bad, but it's still clicking. And
Well, this is really high tech and useful for the military, and I suspect that it'll be useful in the civilian world too over time. If you get the price point down, I would much sooner have this than with the glass. And my guess is it lasts longer also, and it uses new technology. Fabulous. I'm glad you got it. What a difference since 1995 when we met.
Hey, keep reminding us of our
Sorry.
age, my friend.
That's Guy Akasaki. We're actually not done. There's more to talk about. He's got other things, but we're out of time. Guy Akasaki from Commercial Roofing, GreenPath Technologies, looking at the edges of everything here in first responder technology and energy efficiency for tomorrow here on Code Green. Thank you so much, Guy.
Thank you.
Aloha. Thank you, Dana.